What's up everyone, Patrick here, welcome back. Moving on to another example, very similar to the last video. We have to find the x-intercepts of these quadratics here, and then we have to draw a rough sketch of it. So when I'm drawing the rough sketch of these, what I'm going to focus on is the x-intercepts since we're going to find those. So I'm going to sketch those, and then also, these are all in standard form. We could also get the y-intercepts very easily because for any standard form quadratic, as a review, if we want to get the y-intercept, we plug in 0 for x. Well, if we plug in 0 for x, notice this is going to go to 0, this is going to go to 0. We'll get a y value of c. So any quadratic that's in standard form, the c value is always going to be the corresponding y-intercept. So I'm going to graph the y-intercept and the x-intercepts and then draw a rough graph from that. I'm not going to focus too much on finding the vertex. If you want to yourself, you can. Maybe for the first one, I'll find the vertex in two different ways. Remember, we could find it by either finding the axis symmetry, the midpoint between the x-intercepts, or we could complete the square. But then for the rest of them, I'm just going to focus more so on the intercepts because we're focusing on solving quadratic equations still. And the way we incorporate quadratic equations when we're finding the x-intercepts is, well, for the x-intercepts, the y value is going to be 0. So we would plug in 0, and then we would solve this quadratic equation. We're going to find the x values that give us a y value 0, and those are going to be the x-intercepts of the quadratic. So first thing we always look for, can we take out a greatest common factor? Notice between 4, 24, 27, we can't. So let's see if we could factor by decomposition. And so the AC value is going to be 4 times 27, which would give us what, 108. And so we got to find two numbers that potentially multiply to 108 and then add up to 24. And if you do a little bit of trial and error, I believe the two numbers you would get would be 18 and 6, right? 18 times 6 would give us 108. 18 plus 6 gives us 24. So we could take this quadratic here. Let's factor it. So we can factor this or decompose the b value into these two values here. Then factoring by grouping from these two, we could take out a 2x. Then from these two, we could take out a 3. And notice that we're left with taking out a 2x plus 9, that binomial common factor, and then we'll have 2x plus 3, like that. So this quadratic, going back to the equation, it factors into 2x plus 9, 2x plus 3. And so from there, we can find the x-intercepts because we can find when does 2x, when is this factor going to equal 0, when is this factor going to equal 0. And if we isolate for the x values, bring the 9 over, divide both sides by 2, we'll get an x value of negative 9 over 2, or negative 4.5. If you want to work with decimals, this would be negative 3 over 2, which would be negative 1.5. Right, so those are the two x-intercepts there. We could also get the y-intercept pretty easily. Again, it's just going to be the c value, 0 and 27, like that. Okay, so if we graph this, roughly, we'll have 0 and 27, that's like up here. And then we'll have negative 9 over 2, which is negative 4.5, that's like over here, let's say. Let's actually just put the decimal. Sometimes if you're dealing with fractions, it's easier to see the where the decimals are relative to each other. So you'd end up with a quadratic approximately like that. And so the vertex would be somewhere over here. Okay, so that's how the quadratic looks like. That's how you find the x-intercepts. Now, if you want to find the actual value of the vertex, well, we could find the axis. So we would do negative 4.5 plus negative 1.5. We're going to divide that by 2, which would be negative 6 over 2, which would give us negative 3. So this vertex here, it's going to have an x value of -3. If you want to get the corresponding y value of the vertex, you could take that -3 and plug it into the quadratic. So what would this be? This would be 9 times 4, which would give us 36. This here would be -72 plus 27. So this would be what? -36 plus 27, which would give us -9. So -3, -9 would be the vertex. And notice that that makes sense too graphically, right? -3 is in between -4.5, -1.5. And -9, which is a negative y value, would be down here. It wouldn't make sense if the vertex was like over here, for example, because then it would be a quadratic that's opening down. Another thing, the quadratic is opening up, which makes sense because we have a positive leading coefficient. So we could be pretty confident that this is the graph. Another way to find the vertex, if you want to, you can complete the square. So we could change the standard form to vertex form. Again, this is not what this video is about. I'm not going to do that for the rest of these, but just showing you just a quick review of ways you could find the vertex if you want to find the vertex for these other ones. So for completing this square, we factor out from these two, we got to make sure the x squared is by itself. So we end up with that. Then we take the 6 divided by 2, square it, which would give us 3 squared, which would give us 9. So we'd have 4x squared plus 6x plus 9 minus 9 plus 27. Take the -9 out, multiply by the 4, which would give us -36 plus 27. And then this is always going to be a perfect square trinomial. And then we're going to end up with -9, like that, right? So this quadratic and this quadratic are the exact same thing. And then notice that from this vertex form, we can get that vertex -3, -9. Right, so we've done all of this in previous sections. We've done a bunch of examples of finding this vertex. So hopefully you're watching this on the site, watching it in order. If you need to go back to those previous sections, if you're watching this on YouTube, you can go to the site. There's a link in the description box where everything is following in order. Okay, again, we're not going to be focusing too much on the vertex. I'm just going to find the intercepts and the x-intercepts and then the y-intercept. But if you want to find the vertex as well for these graphs, you can do that. Okay, so that's what the graph would be for part A. Now for part B, we got y equals -15x squared plus 12x. So let's find the x-intercept. So we could take out a -3x from these. So we'd be left with what? 5x minus 4. Right? This divided by -3x is 5x. 12x divided by -3x is -4. And so from here, we could tell when does x equal 0? Well, when x is equal to 0, when does 5x minus 4 equal 0? That's going to happen when x is 4/5. If you want to get the decimal value to be able to plot it a little bit easier, it would be 0.8. And then because the x-intercept is 0, the y-intercept is also 0. It's going through the origin, pretty much. Right? Because if we plug in 0 for x, 0, 0, there's no c value. So it's like a plus 0 over here. So the y-intercept is 0 as well. Okay, now if we graph this, it's going to go through the origin. That's one of the x-intercepts. The other x-intercept is 0.8. Let's say it's over here. So it's going to be 4/5. And then you got to be careful because now from all of this, because it's going through the origin, there's no y-intercept up here, which would... there's no y-intercept up here, right? The x-intercept, the y-intercept's the same, so you can't tell just from these 2 points whether it's going to open up or down. But if you look at the leading coefficient, it's negative, so this graph, it's actually going to be opening down like that. So out of all of these graphs, this one would be a good one to find the vertex for, just because it's not obvious just from the points. When you have x-intercepts that are other than the y-intercept, you'll have 2 x-intercepts, then a y-intercept, then you can see how the quadratic is going to be. But with this quadratic, you got to look back, see that the a value is negative, so it opens down. And again, if you want to find that vertex, you can, right? The x value would be 0.4, which is in between 0 and 0.8. You plug in 0.4 here to get the corresponding y value, right? But approximately, that's how this graph looks like for part B. Now, part C, we'll have y equals, so let's again find the x-intercepts by solving this quadratic equation. So this here, we can't take anything out initially from the quadratic. Let's see if we could factor it with decomposition. So the a value is 12, the b value is 11, the c value is -5, the ac value is -60. Two values that multiply to -60 and then add up to 11. So that would be what? -15 and 4? Or sorry, positive 11. So -4 and 15. Like that. And then we could decompose this middle into those two values. Like this, and then from these two we could take out a 4x, so we'd be left with 3x minus 1. Then from these two we could take out a 5, we'd be left with 3x minus 1. Then we could take out a 3x minus 1, and we'd be left with 4x plus 5, like that. Okay, so going back to the equation, this factors into 3x minus 1, 4x plus 5. Right, so now we could solve for the x-intercepts with these two factors. So when does 3x minus 1 equal 0? That's going to happen when x is 1 over 3. There's one of the x-intercepts. When is this going to equal 0? When 4x is -5, or when x is -5 over 4, like that. Okay, if you want to get the decimals. By the way, if you want to also put these in coordinate form, it would be like 1 over 3 and 0, -5 over 4 and 0, right? Corresponding y value is always 0 for the x-intercepts. Then you have certain values for the x values. So sometimes the solutions might just give you the values for x. Sometimes they'll be in coordinate form. And then if you want to get the decimals, just so we can kind of graph it maybe a little bit easier, I think those would be the decimals. So what would happen is we'd have 0.33, which would be like over here. -1.25 would be like further down here. You want to try to keep this a little bit to scale as much as possible. So you could tell that the vertex is going to be on this side, right? Because the vertex has to be in the middle of -1.25 and 0.33. So that's going to be like somewhere over here. Okay, I'm not sure what the exact value is going to be. You can get the approximate decimal value easily, but with the fractions, it would take a little bit more algebraic work. And then the y-intercept, also the c value, is -5. So it's going to be like right over here, 0 and -5. So the vertex is going to be somewhere like down here. Okay, and that's how the quadratic is going to look. Okay, so again, we're not finding the exact value, the exact location of the vertex, but from all of this information, you can get an approximate location here on the graph. Okay, so that's how the graph for part C is going to look. Then moving on to part D, we got y equals, so let's first find the x-intercepts. So first thing we can do, notice that we have a negative that we're working with here, negative leading coefficients. So I'm actually going to take out a -1 to begin with, just to make this positive. So now let's see if we could factor this quadratic. All right, so we'll have an a value of 3, a b value of -1, a c value of -14, an ac value of -42. Two numbers that multiply to -42. add up to -1. So we'll have, what, -7 and 6? Like that. So we'll have 3x squared minus 7x plus 6x minus 14. From these two, we could take out an x. From these two, we could take out a 2. Then we could take out a 3x minus 7. And then we'll have an x plus 2, like that. So remember, we took out a -1 initially. So this factors into negative, and then we got these two factors, like that. Okay, and then from here, we can easily find the x-intercepts, right? Because we just have to find when do these two factors equal 0. This is going to happen when x is, what, 7/3. This is going to happen when x is -2. Okay, so this, as a decimal, it's going to be, what, 2.33 approximately. This is going to be -2. And then we have a y-intercept of +14, 0 and 14, like that. So if we draw this out, we'll have 0 and 14, like that. Then we'll have -2, which would be like, let's actually keep this to scale. 1, 2. So -2 would be like over here. And then +2.33 would be like right here. Okay, so notice that the axis of symmetry, the midpoint between these, is going to be somewhere like over here. It's going to be like 0.16-ish, 0.17, right? 2.33 plus -2 would give us 0.33 divided by 2 would give us approximately 0.17 if we round it. And then notice that this quadratic is going to be opening down because the leading coefficient is negative. So the vertex, and then it has to go through this point, right? So the vertex is going to be somewhere like up there. Okay, so what's basically happening, let's maybe actually move this intercept up a bit. It's going to look something like that. It's not the most symmetric, but hopefully you see what's happening here. And then we got this at 0 and +14. Right? So that's how the quadratic is going to look approximately. If you took this into decimals and graphed it, you should get something like that. Again, we're more so focusing on getting those x-intercepts. The graphing of it, it's just a bit of an extra thing that I'm adding in, just so you can see how it all kind of fits together. But sometimes the graph could be tough because we're not finding, in this video, we're not focusing finding the location of the vertex. But approximately, that's what it's going to look like. And then part E, we got 80 minus 50x squared. So this I'm actually going to rewrite as -50x squared plus 8, like that. Rearrange it so the leading coefficient is first. To find the x-intercepts, we could take out a -2 from everything, like that. And then this here factors into 5x minus 2, 5x plus 2, like that. Right? That's a difference of squares. And so when does 5x minus 2 equal 0? When does 5x plus 2 equals 0? This is going to happen when x is 2/5. This is going to happen when x is -2/5. Like that, right? So notice that the x-intercepts are plus and minus of each other. That's what happens with a difference of squares, which means that the y-intercept, which is going to be 0 and 8, the c value, this is actually also going to be the vertex, because notice that we got -2/5, we got +2/5. Well, notice that the axis of symmetry is going to be 0. That's going to be right in the middle. And then we got the vertex of 0 and 8, which is the y-intercept as well. If you remember, just in general, I've gone through this in previous videos. If you have a quadratic like this in this format without that bx value in front or in the middle, this is always going to have a vertex at 0 and c, right? Which in this case is 0 and 8. And it makes sense because the x-intercepts we found, 2 over 5 and negative 2 over 5, the middle of those is 0, right? 2 over 5 plus negative 2 over 5, we would have 0 in that numerator. When we're finding the axis of symmetry, then dividing it by 2, we get an x value of 0. So that's how that graph is going to look. And then finally, part F, we're going to have, again, let's get into finding the x-intercepts first. So we could take out a 5 from everything. So we'd have 9x squared plus 12x plus 4, like that. And then this, I think, is going to be a perfect square trinomial because we're going to have an a value of 9, a b value of 12, a c value of 4. AC value is going to be 36. Two numbers that multiply to 36 and add up to 12, it would be 6 and 6. Right, so that middle term we can decompose. By the way, you might have at this point a quicker way that you go through in terms of factoring. I'm just keeping it super fundamental over here. Sorry, we can't take out a 3 from the 4, we can take out a 2. So I'm going through the whole process. But again, if you have a quicker way, then feel free to use that. We're left with a 3x plus 2. So notice this is a perfect square trinomial because those two factors are the same. So basically this, remember we took out the 5 initially, so we got a 5, 3x plus 2 squared. And we've gone through many perfect square trinomials. What happens is we end up having one factor, or one x-intercept, which is negative 2 over 3. And with a perfect square trinomial, that one x-intercept is also the vertex. So all we have to do really is we graph this negative 2 over 3 and 0. And then this is a positive leading coefficient, so it's opening up. And then notice that we also have a y-intercept of 0 and 20, which would be like over here. Okay, so that's how the graph is going to look. Whenever you have a perfect square trinomial, the vertex is always going to be on the x-axis. It's going to be that one x-intercept that you have. The only way you can have one x-intercept with a quadratic, if you think about it just graphically, is only if that vertex falls on the x-axis, right? Because if it'll be below this, then you'll have 2. If it'll be above, then you'll have none. Right? Those are the 3 different possibilities for the number of x-intercepts. You could have 0 x-intercepts, 1 x-intercept, and that happens with a perfect square trinomial, or you could have 2 x-intercepts. Right? So for part F, that's how that graph looks like.